students, welcome back to this Ignited Max. At this video, we are going to do the chapter of determinant and matrices of the exercise 4.3 11th standard MH board. This exercise is completely based on the application of determinant. That is nothing but by Kramer's rule we have learned it, and area of the triangle also we can find by the determinant, and we can find the collinearity also with the determinant. Yes, this is completely based on the application of determinant. Related to complete concept, I have already posted a video. Please go through the description link. Even the playlist of the determinant and matrices chapter is also ready. Please get it. First main question, the fourth sub question I took, in which the question says that solve the following linear equation by using the Kramer's rule. We have the equation given at the question and we need to solve by the Kramer's rule. Yes, this is nothing but the first application of the determinant. Let's get started. Now, I took the fourth sum because a fourth sum is complicated in comparative to first, second, third. So I took the fourth sum. Let's get started. The equation given, we have three equations. Yes, the first equation is mentioned over here, the second equation and the third equation. So total there are three equations. But the 1 by x term, 1 by y term and 1 by z term, it's repeated in the three equations. So we need to substitute by the other variable. That is nothing but a, b, c, p, q, r is up to us. So we can substitute that 1 by x is equal to p, 1 by y is equal to q and 1 by z is equal to r. Afterwards we can resubstitute it while getting the answer of x, y, z. But for solving in the Kramer's rule, in the simplest way we need to substitute. Okay, so after substituting it, just put the value at the linear equation given. We need to put this value, that is PQR, at this linear equation. So let's put the value of it. Okay, I have split it in 1 by x, 1 by y, 1 by z in each and every equation so that it will be easy to substitute the value. So I have substituted over here, that is nothing but 1 by x is equal to p. That's what I have written over here. 1 by y is equal to q. Yes, 1 by z is equal to r. The same thing I have repeated in the three equation. Total there are three equation. Yes, after substituting it, we have three equation. Now what is the third equation? If we will see it, it is nothing but 2p minus 3r is equal to minus 11. Yes, so the q part is not that. So we used to write 0q. It's nothing but 0. So write the coefficient term as 0 at the q variable. Rest all the term will be as like us. The discriminant, in which d is equal to determinant, we need to put it, and we need to write each and every coefficient in which it contains the variable term. That is, the variable is PQR. We need to write each and every coefficient which has the variable from the three equations. First equation, second equation, third equation. At the first equation contains of PQR, so the coefficient term is minus 2, minus 1, minus 3. We have done with it. Now the second equation, 2, minus 3 and the 1, we have written with it. Now over here the third equation, 2, 0 and minus 3, and we need to find the value of the determinant of 3 cross 3. Okay, to find the value of the determinant also we will be getting at the description link. We can take any of the row, any of the column. We can expand any of the row, any of the column. We will be getting the answer same. So for the reference, I have expanded the first row. Yes, we can see over here the first row elements are present over here, and I have done the expanding of the first row and I got the answer as minus 44, and which d should be not equal to 0. If, for example, d is equal to 0, then the solution will not be present. Yes, but at the dp value, in place of p over here, p, okay, we need to write the constant term. What will be the constant term? The equation contains the constant term. Yes, the three equation contains the constant term. That's what we need to write over here. And in place of q and r, same as like us. Okay, rest of the term will be as like us. Only at the p variable we need to write the constant term. Okay, after doing it, again the 3 cross 3 determinant occurs. So we need to solve the value of the determinant of the 3 cross 3. We will be getting at the answer. But the dq term. Yes, so the dq term also we need to write in the determinant form. We have done with it. Now P term we need to write as like as in place of Q, okay, dq, in place of Q we will write all the constant term from the three equation given. Yes, we have done with it, and the R variable as like as, and we got the determinant form. Even over here also I have expanded by the first row only. Even we can check it for the other row, other column also. Even we can expand other row and other column also. Okay, we got the answer as minus 88. Now the dr value, that is nothing but P term and the Q will be as like a same, and in place of the R, okay, dr, so we need to write all the constant term from the three equation given. We have done with it, and we need to solve the value of the determinant of 3 cross 3 by expanding any of the row, any of the column. Okay, we will be getting at the answer as minus 44. The dp value, there is not restriction that dp should be not equal to 0. Whatever may be the answer will be accepted, but at the d value it should be not equal to 0. For what purpose? We will be getting the solution at the done with the d value, dp, dq and dr. We got the answer. Now let's put the Kramer's rule formula, that is nothing but p is equal to dp by d, Q is equal to dq by d, and R is equal to dr by d. And let's substitute the value respectively, and we got the answer also. Now we have came across the p value, q value and r value, but from the question given it is 1, we have substituted it, that is nothing but 1 by x is equal to p, 1 by y is equal to q and 1 by z is equal to r. We need to resubstitute it. That's what I have done over here, and afterwards we'll be getting at the answer as x, y, z. That's what we need. So x is equal to minus 1 by 4, y is equal to 1 by 2, z is equal to 1 for the first, second, third sum. Okay, on the question number 1, no need to substitute and resubstitute. Okay, only this part is enough and we will be getting the answer. No need to substitute at the first, second, third. Second main question, the question is given as a word problem sum. That is nothing but at the previous sum we have got the equation and we have solved by the Kramer's rule formula. Yes, but over here we need to do the equation, that is from the word problem sum we need to create the equation. How we need to create it? Let's get started. Now the question I'm just reading off. The sum of three number is 15. If the second number is subtracted from the sum of first and third number, then we get 5. When the third number is subtracted from the sum of twice and first number and the second number, we got 4. Find the three number. So it's completely based on the three numbers. That is nothing but first number, second number, third number. That what it's repeated in the word problem. Yes. So let's take the first number be x, second number be y, and third number be z. Okay. Now let's substitute in each and every equation. So this will be my first equation. Yes, the sum of three number is 15. That is nothing but total there are three numbers. That is nothing but x, y, z. So the sum of three number is 15. So x plus y plus z is equal to 15. Yes, this will be my first equation. And the second equation, if the second number is subtracted from the sum of first and third number, then we got 5. That is nothing but the second number is y, okay, is subtracted. Okay, the second number y is subtracted. That is nothing but minus y from the sum of first and third number. Sum of first and third number is nothing but first is x and third is z. So if we will sum the third number, then we get 5. Yes, this will be my second equation. That's what we have mentioned over here. Okay, just remove the bracket and we'll be getting the answer. Now one more equation. When the third number is z, okay, is subtracted from the sum of twice and the first number and second number, we got 4. Yes, we have mentioned over here. Okay, the total there are 3 equations is completely ready. Let's get started with the Kramer's rule formula. Total we will be getting the 4 types of determinant, that is nothing but d, dx, dy, dz. Yes, the same thing as we have done for the Kramer's rule previously. Okay, the first main question, the fourth sub question we have done with it. The same problem we need to apply over here. Okay, we have mentioned over here also d value, dx value, dy value and dz value. Okay, the same procedure we need to apply. Okay, no need to worry about it. Only the problem is d should be not equal to 0. Okay, the rest of the things will be absolutely same. Over here dx, in place of x variable coefficient we need to write the constant term, y variable coefficient we need to write the constant term at dy, and dz, the z value, okay, z variable coefficient we need to write the constant term from the equation given. And we need to find the value of determinant of 3 cross 3. Just put the formula of the Kramer's rule, that is nothing but x is equal to dx by d, y is equal to dy by d, z is equal to dz upon d, and we will be getting the value of x, y, z, that is nothing but 3, 5 and 7. We have done with it. The question given us, find the three numbers. We have already substituted that the three number be x, y, z. So we need to find the value of x, y, z, that is nothing but 3, 5, 7. The third main question, the question asks that examine the consistency of the following equation. So total there are three sub questions are given in which we need to examine that the equation is consistent or non-consistent. Yes, then how we need to find? That is nothing but we need to take the value of the determinant. If it is equal to 0, then it is called as a consistent. If the determinant is not equal to 0, then it is called as a non-consistent. Okay, I have made a separate video related to the consistent, non-consistent also. It will be getting in the description link, so no more worry. But still, for doing the exercise 4.3, we are getting the third sum of the first sub question. Yes, so we need to write the equation as like as, and okay, in the LHS part of the equation we need to put the variable of the coefficient term, that is nothing but 2x minus y plus 3 is equal to 0. We need to convert as 2x minus y is equal to minus 3, whatever may be the constant term. Okay, over here minus 2, over here minus 3, just take it in the RHS value, and rest all terms as like as. Now we need to take in the determinant form. Yes, we have took it. If it is equal to 0, then only it is called as a consistent. If it is not equal to 0, then it is called as a non-consistent. Okay, let's take the LHS value. That is nothing but over here we have found the value of the determinant by expanding the first row. Okay, even we can expand any of the row, any of the column, no problem, we will be getting the answer same. So is equal to 0 is equal to RHS, this is what we need. So we have proved that the given equation are consistent. Now rest all the question we need to apply the same technique, we will be getting the answer of it. As we have discussed, we can find the area of the triangle with also the determinant. Yes, we can find the area of the triangle with this determinant. That is nothing but is one of the application of the determinant. That's what the question 5th asks. Okay, 5 main question, and which it asks that find the area of the triangle whose vertices are given. Okay, the specific vertices are given like A, B, C, P, Q, R, M and T. Okay, on the first, second, third sub question respectively they have mentioned it, and we need to find the area of the triangle, that also with the determinant. Let's get started. So the coordinates are given. Okay, we are doing the second sum of it. The coordinates are given of PQR. Okay, so I have written in x1 y1, x2 y2 and x3 y3, because at the formula of area of triangle is equal to half of the determinant form is given. So just put the values respectively. If we are putting the value of x1 y1, x2 y2 and x3 y3 from the question given, we will be getting the answer. By expanding the row we will be getting the answer, and at last we got as minus 25 by 8. Okay, but the area of the triangle, the area cannot be negative. Okay, as the area cannot be negative, so take the mod value of the area given, like minus 25 by 8. So what will be the mod value? Is equal to 25 by 8. So the area of the triangle is 25 by 8 square units. Okay, so related to it also the description link, we will be getting the video. The 6th main question, in which the question asked find the area of the quadrilateral whose vertices are given of A, B, C, D. At the quadrilateral, so total there are 4 vertices in which they have given respectively, and we need to find the area of the quadrilateral. But In the application of the determinant, we found only area of the triangle with the determinant, but we have not got the complete concept of the area of the quadrilateral. That is nothing but when the quadrilateral is designed as A, B, C, D, we have written the coordinate. If we will construct the segment AC, we will be getting the two triangle. Yes, so we need to find the area of the triangle of ACD and ABC, and at last we will be finding the area of the quadrilateral. If we will sum both of the triangle, we will be getting the area of the quadrilateral. Here is the solution for it. Okay, area of the quadrilateral is equal to area of triangle ABC plus area of triangle ACD. As previously we have done for area of the triangle found, the same procedure we need to apply, but both the times we need to apply, and if we will sum both the number, then we will be getting the answer is nothing but 21 square units. This is how we need to find the area of the quadrilateral. The 8th main question, they have asked to examine the collinearity of the following set of points, in which we need to find whether the points are collinear or not. That is nothing but we need to find the area of the triangle by the determinant. If the value of the determinant is equal to 0, then it is called as a collinear points. If it is not equal to 0, then it is called as a non-collinear points. So we are going to do the third sum. We need to check that whether the given points are collinear or not. Let's get started. Are the coordinates of the L, M and N. Yes, so we need to find the area of the triangle LMN, that is nothing but half of the determinant, that is nothing but x1 by 1, x2 by 2 and x3 by 3. This will be getting in the given form, and rest all things we need to write as a constant, that is nothing but 1 1 1, and we need to find the value of the determinant by expanding any of the row, any of the column, and multiply by 1 by 2. We will be getting the answer 0, then the given points are collinear. If it is not equal to 0, then it is called as a non-collinear. Even we can check for the first and second sum. Watching this video, if this ignited max is so helpful, then do like, share and subscribe, and don't forget to comment.